Yeah, okay, so I'm Will, and I'm going to talk about how researchers and research groups problematize software and software development work in particular. And I'm going to focus on how different groups problematize it in different ways, they encounter it in different ways, and how different fields and research groups are undergoing different kinds of change around software development work, okay? And so this is part of a longer running set of studies that we've been doing as a lab with a number of groups here at the University of Washington. So Andy Nang and I have been working with different groups, and Charlotte is our advisor, by the way. And actually, I'm sort of realizing that with Nick and Anissa in the room, like 3/5 of my dissertation committee is actually in the room right now. So this feels a little bit like a defense of some kind, but I'm going to try to stay cool. So just to give a little bit of, to sort of motivate this or frame it a little bit, a lot of the studies that have looked at scientific software development in the past have focused on commonalities that we can see in the way that scientists in different places engage software. And so one of the ways of doing this is looking at, if we were to take science as a kind of software development, what kind is it, right? And so this leads us into discussions of like science as end user software development or science as risk averse software development.
Share your screen. Go ahead, keep talking.
But then also the notion of best practices to look at what kinds of practices in all of these for use cases can really help researchers do what they need to do. And these have been really productive lines of inquiry, especially a lot of the researchers that I've talked to have really found the best practices and doing things like software carpentry be really useful. But the approach that I want to take here is to look not at science or not try to capture what's essential about science across all of these different cases, but rather to look at the patterns in variation across the sciences, to look at the sciences as a complex topology of sites of work that have a lot of different dimensions. They have organizational dimensions, they have technological dimensions, they have lab level cultural dimensions, and so on and so forth. And so I'm going to talk a little bit about how this can be useful, I think, to the specific situation of research software engineering that is coming into these environments, but I'll do that at the end. I think when we have some of these examples in front of us, it'll be easier to see that. And so I'm going to go through a couple of empirical examples, and I want to clarify that although this is part of a longer running study, this is some stuff that we're analyzing right now that we've been talking through. So I'm sort of bringing you some empirical cases that I hope will prompt some interesting topics. And I also want to mention that I think it's really obvious to anybody who's been in these spaces, who's been doing this work, that sites of scientific work in different disciplines or in different institutional situations, national labs versus academia, are very different sites of works that have a lot of different dimensions. But I'm trying to bring that out and so that we can talk about it explicitly, because I think that's a productive thing to do. Okay, so the first, I'm going to do this through a basic sort of comparison of two field sites that we're involved with. And the first one is an oceanography group that's here at the University of Washington. And this is actually Andy's field site. So he's been working with this for 6 or 7 years. We've recently published some papers on that are really interesting if you want to go look at them. And this is a group that's here at the University of Washington, but they work with a lot of other groups in a larger field, and they do a lot of data collection out at sea, collaboratively using these instruments, but they also do sort of lab culturing work. And then there's been a big change in that field, especially around using software to analyze a lot of data that's now coming off of DNA sequencing technologies in the last couple of decades. The second site that I'm going to talk about is in the field of cosmology. They're radio astronomers who a lot of their work is organized around large telescope projects that build arrays of radio antennas out in the desert in South Africa and Australia. And they also work in sort of large groups of labs trying to do for signal processing and then data analysis of signals sensed by these large telescope arrays. Okay. So I'm going to spend the rest of the talk talking about these two sites, so I'm just going to get right into it. And the way that I'm going to approach this is talk about a couple of axes or dimensions along which these two sites vary from each other, okay? And the first one is generational gaps. And this really has to do with the fact that in the radio astronomy field site, programming, maybe not software engineering, but programming has been part of the work of doing research for a very long time. It's something that's built into doing a PhD in the field, being a researcher in the field. You do programming as part of that work. In the oceans group, this is something that's becoming much more prevalent in their subfield because of DNA sequencing technologies. And so it's not something that was built into a lot of these timelines and degree programs and trainings that they have. And so we can see this with one of the postdoc who's here at the University of Washington. She says, it's crazy how most PhD students these days know how to code. When I started, we didn't have these instruments that create this kind of data that we would need these kinds of skills for. When I first started, there was no motivation for me to learn these skills. I don't know how Anya feels, but I suspect that she has been surprised at how slowly we've been able to get from an instrument to a story. And I think she expected that to be faster. And so I want to point to a couple of things here. Anya, by the way, is her advisor. Not advisor, the professor that she's working with. And I want to point to a couple things. The first one is that there's a sort of large jump in the kind of work that they have to do between generations of researchers coming into this field. And so in the radio group, by contrast, new researchers coming in as PhD students, they do have to learn programming. They have to learn these languages. But it's they understand that that's part of the work. It's built into timelines for PhD students. It's built into timelines for doing research projects. In the Oceans group, it's not a known entity. And so there's a lot of new work. PhD students have to come in and spend 2 or 3 years building these pipelines that didn't exist previously. And so there's a lot of extra work, but it's also unexpected work or unknown quantity of work. But the second thing I want to point to is a sort of difficulty in communicating between an advisor and a student around this work, because in a lot of cases, advisors have a hard time advising this kind of work because it's not something that they did as part of their degree. And so they're in the position of not understanding how difficult it might be to develop a certain kind of pipeline or to acquire some of these skills. And so there's sort of a breakdown in the mentorship around these particular kinds of issues. And I'll just point to one more quote from Casey here. She says, I don't think Anya really understands it, to be honest. It's like, I think she knows, when she studies a paper that like, there's this new pipeline, this tool you can use. I think she thinks it's a little more plug and play than it is. And maybe for people who are more like experienced with putting together different pipelines or different parts, different tools into a pipeline, it is more plug and play. But for me, it's really not. And I don't want this to turn into advisor bashing, because she has all positive things to say about the person that she works with in the rest of this interview. But I do want to emphasize this point that there's this breakdown and difficulty in sort of advising and knowing not only how long these things take, but what kinds of tools, software pipelines, software packages can be for science, and not understanding what they can do, how they can be put together, and how to use them yet. That's something that is a very new thing in this field, whereas for the radio group, it's not as new in introduction. So the second thing that I want to talk about is the installed base. And the installed base is kind of a funky term, but it's a term that I'm borrowing from studies of large technical systems and infrastructure. And it captures this situation that you can be in. It's sort of a historical position of when you're trying to do something new, but in the past, you as a group or yourself, you've committed to certain technologies or standards that you now have to work with, right? They sort of constrain what you were able to do because you're working with something that you've already committed to. And this is something that was particularly salient for the radio group, in part because there's a long tradition of doing programming and pipeline development work in that field. They have a lot of pipelines lying around, and not all of them are wonderfully documented and so on and so forth. But also there's a lot of different data formats that are associated with these different analysis software packages that existed that have been sort of gradually accumulated in the field. And so they realized that a big area where errors and mistakes and miscommunications were coming in was in translating between these data formats. And they're really working on this sort of fragmented landscape of different data formats and technological resources. And so in developing this software in the middle is one that I'm following in that field site. And the circles around it are all of these different data formats that they were trying to communicate between. And this software in the middle has received a tremendous amount of the sort of best practices that we might associate with getting closer towards software engineering. And so this is much more the change that this group is undergoing. Programming was a big part of their work, but what they're doing is reworking the kind of software development that they're doing in order to handle some of these cases, to have a robust process for handling all of these different technical systems that they have to work with. They've been lying around for a very long time. And we can contrast this with the Oceans group, where they do have commitments to certain instrument technologies and other certain proprietary software that they use. But in terms of these bespoke pipelines that they're developing, they're actually, they have a relatively blank slate, because programming is a fairly new thing in their subfield. And so they have a little bit less baggage to deal with, which is a very different situation to be in. So the third thing I want to talk about, and this is a mouthful, is heterogeneity of career trajectories. And so in the radio group, there is a lot of variety in terms of people's expertise and knowledge over certain physical phenomena and certain computing resources or technologies. But in the Oceans group, there's actually a tremendous variety in this regard. So in the Oceans group, there are people who have a background, an undergraduate background in oceanography, who have come in and are picking up software as part of their research. There are people like that. But there are also, for instance, there was a professional software developer who had a decades-long software development career in industry, who was an avid diver and then came in to do a PhD in this lab. But there was also a researcher who came in with a background in oceanography, an undergraduate background, but discovered that he was competent and passionate about doing a lot of what he called scripting jobs and dealing with cloud computing and databases and so on and so forth. And so he's sort of stepped into a role doing that kind of work in the lab. But he is not, in contrast to the software developer, he wasn't oriented towards doing research. And so that's another distinction that exists within these two labs. Is that this is Roxanne, who's a data manager in a different lab here at UW. She says she's describing how she came to have this role that she has in the lab that she's in. He says, that was the impetus for bringing me on. They just needed more hands, more eyes on the technical work of the lab that was not focused on producing a paper and getting a degree, because people who are doing that have so much on their plates already. They just don't have time to learn how Git works and how to set up a functioning GitHub, stuff like that, and maintain a functioning GitHub. And so this is something that probably you all have seen before, this sort of distinction of being oriented towards research outputs versus not being oriented towards research outputs. But what I really want to focus on here is the difference between the two labs in this regard. That in the radio group, there are almost everybody is a physicist doing research who has picked up software. Whereas in the Oceans lab, there's a tremendous variety of people with different orientations. I've also run into statisticians who are coming through that group. And so there's this is another kind of thing you might run into in different groups. Okay, so the last thing that I want to talk about is organizational environment. And this is a really vague term, but I think you'll see what I'm getting at when I start describing it. So this is something that was, again, particularly salient for the radio group. The Oceans group has a complex organizational environment. And I mean, who doesn't have a complex organizational environment? I have a complex organizational environment. But the radio group, the complexity of their organizational engagements and environment and changes in that organizational environment really came to shape the way that they engage with software. And I'll explain that a little bit. So this is the same software package that I showed before that I've been following in this group. And the three circles are different collaborations that rely on this software and contribute to it. And then the little circles are researchers who have contributed to the software, and the colors are different universities that they're at. And so you don't need to track all this, but the basic point is that they're in a situation where they have groups of researchers contributing to the software who have, they belong to different university organizations, and they belong to different collaboration associations. And those two groupings are weirdly overlapping sets of some kind, right? And this is something that is a really salient part of their work, because about 10 years ago, when they were applying for new funding to build a new telescope, they went to NSF and they were asking for more funding. And NSF said, okay, great, but we have this other collaboration of labs that's also asking for funding. And so now you need to work together. We're only going to fund one telescope. And this is apparently something that NSF does fairly often. I didn't realize this, but they refer to this fondly as the shotgun wedding of the two collaborations. And so this was an event that there was a sort of a moment of realization that now we're going to have to develop these pipelines across all of these collaborating labs. And our work is going to be very tightly coordinated here. And so we can look at this. This is one of the research scientists in that group. This is actually a Slack exchange where she was explaining them picking up the process of deprecation with one of the other collaborations that she's actually part of too. They said PyCosmos, and PyCosmos is a pseudonym, by the way. PyCosmos responsibilities towards collaboration 2 are a matter of ongoing discussions, which is a great phrasing. Most of the PyCosmos contributors and all the maintainers are involved in collaboration 2 at some level. And collaboration 2 adopted PyCosmos as a foundational library early on. We have agreed as a matter of courtesy to run continuous integration testing against some of their repos. Failures on those runs don't necessarily prevent PyCosmos PRs from moving forward, but they do make us aware of potential issues so they can be addressed as early as possible. And so you can see here that there's a very tight coupling in the software development work that has to go on between this software package and software packages that are being developed elsewhere in this organizational environment and other collaborations and with other research groups. And this is something that it looks very different from the kind of model that the Oceans group is closer to, that looks a little bit more like what a lot of the sort of policy discussions around software reuse looks like, where you do some analysis with some code and then you publish a paper and you publish the code with the paper to a sort of a public audience. And then there's the issue of like validating or checking that software. This is much more like an ongoing development relationship within an organization. And a lot of the way that they're changing the way that they do software, a lot of the impetus for changing the way they do software is to resolve these coordinative difficulties that they were thrust into, okay? And so that's one of the ways that that's one of the core ways that they think about software and changing the way they do software. So to step back, I'll try to package these up a little bit. The Oceans group is engaging in software development as a new kind of practice that they're taking into their work, as a way of dealing with new kinds of data and new amounts of data that are coming off of new instruments that have entered the field in the last couple of decades. And in doing that, they've really introduced a lot of variety in the kinds of skill sets and career trajectories that exist in the lab, which is sociologically interesting. The radio group, by contrast, exists in a field where programming has for a very long time been part of the work that they do, but they found that they need to change the way that they develop software in order to help manage these collaborative difficulties, and especially within a field that has a lot of established data standards that they need to work across, okay? And the radio group definitely has to worry about performance and optimization, but there hasn't been a recent change. It's not in a new ballpark in recent years. And so that's not, at the moment, that's not something that's really driving the way that they are changing their software development work. So I said that I would talk a little bit about why I think that it's useful to look across these different research groups this way. And the first thing that I want to say on that point is just that the goal here is not to try and outline every possible dimension along which sites of work might vary, because that's going to be a lot to an infinite number of ways, depending on how you characterize it. But I do think that it's looking across these and looking for sensitizing yourself to the kinds of variations that you might find in different sites of work can be specifically useful for the situation of hopping sites of work. And this is something that ethnographers who are studying scientists are in, of hopping from different disciplines to another. It's something that I think a lot of people who are in data science roles find themselves in, of jumping from different sciences to another. And I've seen statisticians, I've run across statisticians doing this as well, but I think it's something that RSEs are also going to be deeply engaged in doing. And it's something that's kind of difficult, right? And so how can it be helpful? I think that it can be helpful in orienting yourself quickly, thinking about paying attention to these differences in this way. It can be helpful in generating the right questions for going into new sites of work, of orienting yourself quickly, being able to, I mean, if you're parachuting into some whole new discipline and you're going to be there for 4 or 6 months, you don't want to spend 2 to 3 months just trying to figure out what's going on there, right? But also it can help understand problems that people have around software, the goals that they have with software on their own terms, right? In some cases, really, maybe what they're looking for is performance or optimization problems. In other cases, maybe it's usability or resolving coordinative difficulties that they really want to do with software. And then the last thing is just that I think research software engineers, whether they really want to or not, a lot of the stuff that they're going to end up doing in these sites of work is not going to be just engineering software. It's going to be consulting type work and communicating type work of helping people make decisions about what technologies to commit to, which is going to become part of an installed base, and doing work communicating how long things will take, how difficult things are, whether things are even possible, and that kind of thing. And so I think understanding these sorts of contextual elements in these sites of work can really help in that kind of work. So that is all I had.